Let's talk now about the fabric policy plane. The policy plane in the fabric is the plane that is in charge of providing security and segmentation. By security, we are talking about performing network access control, identifying devices, um, executing policies, security policies, based on access control lists. And by segmentation, we're referring to terms such as macro segmentation and micro segmentation. Remember that macro segmentation um, lets me create different routing domains within the fabric, and micro segmentation lets me create groups that live within virtual networks. And I can have users or end devices identified by these groups. And the technology that lets me perform these duties in the fabric is a Cisco TrustSec. And in order to have TrustSec in the fabric, I need ICE servers or identity service engines. So the short answer to the question, who is responsible to perform the duties of the policy plane within the fabric, that will be Cisco TrustSec. Um, as we're going to see later on, we will see that that is not a complete answer, but most of the documentation refers to TrustSec as the policy plane. But you can continue watching if you want more details. So let's go into more details. With the Cisco TrustSec, we are no longer using IP addresses or VLANs numbers in order to define access control lists for my security policies. We are going to use identities. So in traditional networks, we will use IP addresses or VLAN numbers or port numbers or MAC addresses in order to define traditional access control lists or VLAN access control lists or port-based access control lists or MAC address-based access control lists. So with TrustSec, we are not going to use that. We are going to use the identity of the user or a device, and after identifying a user or a device, we're going to assign that into a group. And we are going to separate groups and identify groups from one another using scalable group tags. Remember that scalable group tags are 16-bit wide, so you may have around 65,000 different groups in your enterprise networks. This approach of doing security is known as group-based access control, or GBAC. So by using scalable group tags, I can have, for instance, a source scalable group tag that belongs to a device that is sending packets to a destination device, and the destination device may live in a destination scalable group tag. So based on that, I can execute scalable group access control list. No longer based on IP address, no longer based on VLAN numbers, no longer based on port numbers or MAC addresses, no longer using IP-based access control list or IP-based VLAN access control list or port access control list or MAC address control list. I'm going to use identities of users of device mapped into scalable group tags in order to execute my scalable group access control list. Just a note on ICE. Remember that we said that in order to have TrustSec in my fabric, I will need identity service engines or ICE servers. You are recommended to install at least 2 for high availability. And the best way to place them is, for instance, your shared services block. If you have a shared services block in your network, or if you have an on-premise data center, you can also place your ICE servers there. Notice that this is the current icon for an ICE server. I believe that the former icon for the ICE server was this, like a fingerprint. And an actual ICE server is made of several roles or processes that Cisco calls personas. So that is the meaning of this particular 4 circles here. Then they mean that you're running these roles that Cisco calls personas. The most important one that is the actual the actual process that is going to perform most of the security duties is the PSN, but I'm going to elaborate more on this ICE later on. So let's go back to TrustSec. Remember that we said that the policy plane performs segmentation, and we have 2 types of segmentation: micro segmentation and macro segmentation. In this case, TrustSec only does micro segmentation. And the way it does this is by using the ICE servers in order to first authenticate every single device or user that wants to use the network. So when we plug in a device into the network, or when we are going to try to associate a wireless device into our network, then we are going to perform network access control. We can, for instance, use AO2.1x, and then we are going to communicate with the ICE server. In that case, the ICE server becomes a AAA server, and it will authenticate my device. After identifying who is trying to use the network, that means that at this moment it will going to identify who is trying to use the network. After network access control, then it will assign a tag. So this port will then get assigned an scalable group tag. So every single traffic frame or packet that enters into that port will get assigned that scalable group tag. The same will apply to another device. For instance, I have a printer here. Then when I attach this printer to the network, NAC will kick in. It will identify this printer and then we will get assigned another scalable group tag, let's say scalable group tag B, to this port. So we have this scalable group tag assigned to this user. Let's call this a scalable group tag A, and then this user or device wants to print something. Then we'll have to set up a VXLAN tunnel from this computer to the printer. This VXLAN tunnel will be carrying the scalable group tag that was assigned to this user or device when it was authenticated and identified by the iServer. Now, when this frame wants to go out from the fabric into the printer, then here we can execute an scalable group access control list. And then we will ask, do the users that belong to the scalable group tag A can send packets to the printers that exist in a scalable group tag B? If so, if we are going to allow the packet to go into the printer and print whatever the user wants to print. If if this particular ACE in the scalable group access control is denying this operation, then we will not forward the Ethernet frame into the printer. So that is basically how microsegmentation works with TrustSec. So if you notice, TrustSec is heavily based on scalable group tags. How do we carry this scalable group tag information? For traditional IP networks, TrustSec has two technologies, an inline tagging or the SPX protocol. But for SD access, we're going to use VXLAN to carry the scalable group tag. So within the fabric, we're going to use the VXLAN headers in order to carry the scalable group tag information. But if for some reason we want to maintain this information as packets travel outside the fabric, then I'm going to have to configure my border nodes in order to use inline tagging or SPX if we have a traditional IP network outside my fabric. So if I have a traditional IP network, then I will have to set up my border nodes in order to use either inline tagging or the SPX protocol in order to maintain this scalable group tag information when the packets want to go outside my fabric and I want to maintain that information. Within the fabric, VXLAN will be in charge of transport the tags. Now let's talk about microsegmentation. Remember that TrustSec only does microsegmentation with scalable group tags. But if I want to do macrosegmentation, that means that I want to do virtual networks. That is not a part of TrustSec. And remember that we can need virtual network, for instance, if your enterprise network recently acquired, if your company recently acquired a secondary company, then you can have a virtual network for company A, for user that belongs to the company A, and another virtual networks that belongs to users that belong to company B. Or for instance, you can use also a virtual network for guest users. So you can keep that traffic in different domains. So traffic originated from the guest uh, users that live in the virtual network, in the guest virtual network, will never arrive into other virtual networks. That is the advantage of using macro segmentation. Within the fabric, I'm going to use VXLAN in order to carry macro segmentation information in the form of BNIDs. So VXLAN is going to help me carry that information within the fabric. But if for some reason I need to maintain this VNID information when traffic wants to go outside the fabric into a traditional network, then in my traditional IP network, I will need to set up BRFs. And I will need to configure my border nodes in order to map the BNID that exists within the fabric into a BRF number with a particular route distinguisher and so on. So, in summary, the policy plane activities are performed mainly by TrustSec, because TrustSec will be doing NAC, Network Access Control, identity. It is going to identify my end users or end devices when doing network access control, and then it is going to assign a scalable group tag in order to perform micro segmentation with scalable group tags. Remember that VXLAN is going to carry scalable group tags inside the fabric. Now, when it comes to macro segmentation, VXLAN is going to help me carry these BNIDs within the fabric, and if required, the border nodes will help me carry the scalable group tags information outside the fabric into a traditional IP network using inline tagging or SPX or using BRFs in order to map BNIDs in order to maintain macro segmentation information. Now, let's talk a bit about ICE servers. ICE means Identity Service Engine. The ICE server will talk particular Cisco technology that is known as PX Grid in order to communicate with the Catalyst Center, formerly known as DNA Center. And the ICE servers will be talking REST in order to communicate with my network devices. Now, the scalable group tags are actually administered by ICE. But remember that the Cisco Catalyst Center, formerly known as DNA Center, will be our single pane of glass to manage our network. So you can create your scalable group tags and define your policies through the Catalyst Center. So in that sense, the Catalyst Center, formerly known as DNA Center, is your orchestration device. There is a term that you will come across that is known as policy management plus identity services. That means that you will be mapping users and devices to scalable group tags. That means doing policy management with identity services, and ICE helps you doing that. Now remember that every ICE server is made of certain modules that Cisco calls personas. You can have a PAN persona or policy administration node. It is the persona that will let you administer your ICE server. You can also have an MNT persona or monitor and troubleshooting node. It will be in charge of storing messages from all your PANs and PSN personas. It will help you monitor and troubleshoot your ICE solution, and it will help you create and data reports based on correlated information from all your ICE solution. Now, the real workhorse of ICE is the PSN persona or policy service node. It will perform network access control. It will be actually evaluating policies, making all decisions. So you might want to have ICE servers in a server farm that will be only be running policy service nodes, because this is the persona that will be really busy performing network access control from your devices, assigning scalable group tags, deploying your security policies that are made of scalable group tab access control lists. You can also have the PX Grid persona or Platform Exchange Grid persona. This persona provides your ICE server the ability to talk with other devices that also talk PX Grid. For instance, remember that the Catalyst Center, formerly known as the DNA Center, talks PX Grid. There are other Cisco devices that also talk PX Grid. So this persona will let your ICE server communicate with those devices. So as a summary, the ICE server will provide you with secure network access, increases management awareness control, provide consistency for users and device accessing your network. It is an integral and mandatory device for SD access, implements the control policy. It is the device that will be actually implementing your control policy, provides dynamic mapping of users and devices to scalable group tags, and simplifies end-to-end security environments. That's it.